Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with the same module, that is the database design concepts, but the new chapter, that is chapter number 21, that is the information retrieval. In the last class we have finished with chapter number 20, that is the distributed databases and how to process the query and what are the various functions that is used in the distributed databases and the data warehousing and the mining. Now the next chapter is chapter number 21, that is also a part of the part 5, that is the data warehousing and mining and the information retrieval. So we are finished with the two chapters of this part, that is the data warehousing and the data mining. Now the next chapter, the last chapter of this part, is the information retrieval, that is how to retrieve the information, what are the various ways by which the information will be retrieved, that is the information retrieval, that is the chapter number 21. So in this chapter, we are going to study how to retrieve the information, what are the various modes that is used to retrieve the information, that is what are the various methods, what are the various ways by which we can restrict or by which we can retrieve our information, that is the information retrieval. So textual data is unstructured. Unlike the rigidly structured data in relational databases, the text information retrieval generally refers to the querying of structured or unstructured textual data. Then information retrieval that is used, that is the retrieval system, have much in common with database systems, in particular the storage and the retrieval of data on the secondary device. So whatever the data storage, whatever the distributed system that is used, whatever the data storage that is used on the secondary storage. However, the emphasis in the field of information system is different from that in the database system. So whatever the field, whatever the data that is available in the information system, that is based on the keywords and the relevance of documents to the query and the analysis, classification and the indexing of the document. So whatever the data, whatever the query that is used for the indexing of the document, that is used for the querying of the document, that is used for the analysis of the document. Web search engine today go beyond the paradigm of retrieving the document. So whatever the information, whatever the document that they are receiving, that is used to retrieve the document, that is used to retrieve the various data that is available in the documents. And the address border issues, such as what information to be displayed in response of a keyboard query, that is what type of keyboard query it is used, and to satisfy the information needs of the customer, that is whatever the information that we need, that is run or that is retrieved by the information retrieval method. There are multiple methods by which we can retrieve our information, that is the information retrieval, and that can be displayed to the query, that can be displayed to the keyword query that is used to satisfy the information needs of a user. Then next is the overview of the information retrieval. So the field of the information retrieval has developed in parallel with the field of databases. So whatever the databases that is used, whatever the content that is used with the information retrieval. And in the traditional model used in the field of information retrieval, information is organized into documents. So whatever the model or whatever the content that is used, that is organized in the field of the information retrieval, that is organized in terms of the document. That is a traditional method by which we can take our information retrieval. And that is organized into various documents, and it is assumed that there is a large number of documents that is available, that is used to support the information retrieval. Data contained in documents are unstructured. So whatever data that is contained in the documents are unstructured, that is they are scattered around each other, that is unstructured data without any associated schema. So that there is no schema that is available, there is no associated schema that is available in the information retrieval. The process of information retrieval consists of locating relevant documents. So what is the process in case of the information retrieval that is used or that consists of locating the relevant documents on the basis of user input, and such as the keyword or the example document. So whatever the document, whatever the keyword that is used for the example of the document. The web provides a convenient way to get to and interact with the information sources across the internet. So web is a facility that is used that provides a convenient way to get into interact with the information sources across the internet. So whatever the sources, whatever the internet capacity that is used, that is interact with the information or that is interact with the sources that is used with the internet. That is a we can get more and more information from the web that is used over the internet, that we can contain or that we can get the information over across the internet. However, a persistent problem facing the web is in the explosion of the stored information with little guidance to help the user to locate what is interesting. That is what is interesting, what is going to interest, or what is going to happen in the database systems. Information retrieval has played a critical role in making the web productive. So whatever the content, whatever the criteria that is used as a productive method by which we can play the, or by which we can gain any, or we can retrieve any information, that is played a critical role in making a web a productive and a useful tool, especially from the receiver. For example, if I'm talking about a student, you get the assignment, you search the assignment in the Google, you gain much and more information from the Google. So web provides a high end facility that contain various information that is retrieved in the Google capacity, that is has a Google capacity that contains multiple information. So anyone can search anything, any topic about the, and that may be personal, that may be professional, that may be marketing, any information that we can get from the internet, that we get from the web. So web is one of the productive and the useful tool, especially for the researchers, that is going to research anything, research on the topic, that is going to research on any criteria that is used. Traditional examples of information retrieval systems are online library catalogs, online document management systems, such as those that stores the newspaper article. So these are the traditional example, that is the online library catalog. So there will be a catalog that is maintained in the online method, that is the online library catalogs, and online document management systems, such as those that stores the newspaper article. So whatever the newspaper article that is available, that is retrieved in the information retrieval system. The data in such systems are organized as a collection of documents. So whatever the data that is available, that is organized as a collection of documents. A newspaper article and a catalog entry are example of documents. In the context of the web, usually each HTML page is considered to be a document. That is, every HTML page that is available, that is considered to be a document, or any page that is available on the website, that is available on the web, that is considered as a HTML document, that is considered as a document. A user of such a system or user of such a system may want to retrieve a particular document or a particular class of documents. So whatever the system, whatever the document that is used, that is going to retrieve a particular information, or that is going to retrieve a particular class of documents. The intended documents are typically described by a set of keywords. So whatever the documents, whatever the content that is used, that is described by a set of keywords. For example, the keyword database system may be used to locate looks on database system, and the keyword stock and the scandal may be used to locate articles about stock market scandal. So whatever the scandal, whatever the database system that is used to going on the database management system, that is used to going on the article that is going to deal about the stock market scandal. So we can retrieve any information from the web, we can retrieve any information from the internet. Documents have associated with them a set of keywords. So whatever the document that is used, that is have some keywords, that is some criteria that is used, and a document whose keyword contain those supplied by the user are retrieved. So whatever the document, whatever the content that is used, or that is done by the keyword, that is replaced by the keyword. Next, keyword-based information retrieval can be used not only for retrieving the textual data, but also retrieving other type of data. So whatever the knowledge-based information we are gathering, that is not only used for the retrieving the textual data, but also retrieving other type of data, such as the video and the audio data. So whatever the video data, whatever the audio data that is used, that is also used for the information retrieval, that is also used for the information gathering, that is used for the textual data, such as the video, audio, that have a descriptive keyword associated with them. For example, a video movie may have associated with it keywords such as its title, director, actor. So whatever the activity that is used with the various criteria, while an image or video clip may have tags which are keyword describing the image or video clips. And there are various difference between these models, and the models are deals with the various operations. The first point is, database system deals with several operations that are not addressed informational, or that are not addressed in information retrieval system. So database system, it deal with the various operations that is not addressed in the information retrieval system. For example, database system deals with the update and with the associated transitional requirement of concurrency and its durability. So whatever the concurrency control, whatever the durability control that is used, that is associated with the transaction requirement. These matters are viewed as less important in information system. So these matter that is used, that is viewed as a less important information that is available in the information retrieval information system. Similarly, database system deal with the structured information organized with a relatively complex data model, whereas information retrieval system traditionally have been used much simpler system where the information is organized as a collection of unstructured document. So whatever the information that is used, whatever the data that is used, that is available in the unauthorized access, that is available in the unauthorized manner. That is a collection of the unstructured document that is used in the database management system. The next point is information retrieval system generally deals with the various issues that have not been addressed adequately in the database system. So this is also a system that is used to we can say the deal with the issues or resolve the issues that is available or that adversely affect the database system. So if there is any issue that affect the database system, that issue will be resolved by the information retrieval system. For example, the field of information retrieval has dealt with the issue of querying collection of unstructured documents, focusing on issues such as keyword queries, ranking of document, and equivalence of the document to the query. In addition to simple query or keyword queries that are just set of words, information retrieval system typically allows query information that is used, the logical convention that is used, that is the and or not. So whatever the logical convention that is used, that is also used with the information retrieval. A query containing keywords without any of the above convective is assumed to have and implicitly connecting the query. So whatever the query, whatever the content that is used, that is retrieved with the database document. Then next is in full text retrieval. So whatever the full text retrieval that is used, all the words in each document are considered to be the keyword. So whatever the content that is used, that is available with the keyword, that is available with each document, that is considered as a keyword. And whenever there will be an unstructured document, full text retrieval is essential because there is no information about what words in the documents are keywords. So if there is any word that is available with the keyword that is available in the document, that are known as the keyword. We shall use the word term to refer to the words in a document since all words are keyword. In its simplest form, an information retrieval system locates and returns all the document that contain all the keywords in the query. So whatever the retrieval system, whatever the query system that is used, that will be used as a query management if the query has no connectivities or there is no connective that is used, that is connective is able to handle the more expectations value that is used with the database systems. They use information about term occurrences as well as the hyperlink information to estimate the relevance. So whatever the relevant information that is used with the information retrieval system. The information retrieval system is exemplified by the web search engine. So this is exemplified, this is used by the web search engines and have today involved just retrieving the document based on the ranking scheme. And today search engine is aimed to satisfy a user's information needs by judging what topic a query is about and displaying not only the web pages but also displaying other kinds of information that is used with the various topics. For example, given a query team, a search engine may display scores from ongoing or recent group activity that matches the criteria rather than just display top ranked document related to the cricket. So whatever the example, whatever the search engine that we use, that is going to display the each and every information, that is the information retrieval tool, that is a search engine that is used to give the information about the relevant topic. So suppose if I'm going to search on a topic that is a cricket, so that information will be available and more documents will be available related to the cricket. As another example, in response to a query, New York, a search engine may show a map of the New York, images of New York in addition to the web pages that is related to the New York. So whatever the query, whatever the response that is used as a search engine, that is used as a map of the New York. So if I search for the New York, map is also coming, images are also coming in addition to the web pages that is related to the New York. Now next is relevance ranking using terms. So what is the relevance ranking? So whatever the rank system, whatever the relevance ranking system that is available, that is used with the ranking terms. The set of all the documents that satisfy a query expression may be very large. In particular, there are billions of documents on the web, and most of the keyword queries on a search engine, web search engine, 500 of thousands of documents containing the keywords. So whatever the document, whatever the query that is used, that satisfies a query expression that may be very large in a billions of documents on the web, and more query or more and more keyword queries are available on the web search engine that contains 500 of thousands of documents that contains that keyword. The information retrieval system therefore estimate relevance of documents to a query and return only highly ranked document as answer. So whatever the document that is available, that is giving the estimate relevance of the document to a query, and return only the highly ranked document as the answer. So whatever the answer that is used, that is available with the high ranked document. Relevance ranking is not an exact science, but there are also some well accepted approaches that is used with the relevance ranking. Then ranking using TF and the IDF. So whatever the ranking we are using, that is done using the TD and the IDF. That is the TF is also used, IDF is also used. And the first question that is used with the relevant term T, that is how relevant is a particular document D to the term. So suppose I'm talking about any term, so how relevant or how the information is relevant to the document D to a term. One approach is to use the number of occurrences of the term in the document as a measure of its relevance, on the assumption that relevant terms are likely to be mentioned many times in a document. So whatever the content, whatever the document that is used, that is available in the relevant document. One way of measuring TF dt, the relevance of a document D to a term T, that is TF dt, that is a log 1 plus ndt by nd, where nd denotes the number of terms in the document and ndt defines the number of occurrence of the term T in the document D. So whatever the number of occurrences, whatever the number of terms that is available in the document D. Observe that this metric takes the length of the document into account. So whatever the metric, whatever the length that is used with the various account that is available in the various accounts. The relevance grows with more occurrence of a term in the document, although it is not directly proportional to the number of occurrences. And there are many systems that is used as a TF, that is a term frequency, that is regardless of the exact formula that is using. So there is a term that is a TF DTT or DT, that is D is the defined terms and T is a term that is used with the defined manner. So DT denotes or D denotes the number of terms in the document, and T denotes the term T in the document T. A query queue may contain multiple keywords, and the relevance of the document to a query with one or more keyword is estimated by combining the relevance measures of the document to each keyword that is added up, or that is going to adding up with the various documents. And to fix the above problem, weights are also assigned to the terms using the inverse document frequency, that is the IDF, that is defined as, this is the IDF, that is defined as 1 by NT, where NT denotes the number of document that contains the term T, and the relevance of a document D to a set of Q is defined as this one. And this measure can be further refined if the user is permitted to specify weights for term in the query, in which the case is user-defined weights are also taken into account by using the TFT by WT in the above formula. So whatever the content, whatever the TFT that is used, that is divided or that is multiplied by the weight of the T in the above formula. And the above approach for using the frequency and the inverse frequency as a measure of the relevance of a document is called as the TF-IDF approach. So whatever the approach that is used, that is multiplying the approach, that is the TF and the IDF approaches multiplied by each other. Almost all text document in English that contain words such as and or a and so on, and hence these words are useless for querying the purposes, since their inverse document frequently or is extremely low. An information retrieval system defines a set of words such as the stop words that contains 100 or so of the most common words that imagine or that ignore these words while indexing a document. So whenever we are using the indexing, that is used with the document that is ignoring the values or the words. Such words are not used as a keyword and are discarded if the present in the keywords applied by the user. So whatever the word that is applied by the user, whatever the keyword that is applied by the user, that is defined by the term that is defined in the various terms. another factor that is taken into account when a query contains multiple terms is the proximity of the terms in the document. So whatever the term that is used, whenever the query contains multiple terms, that is defined in the proximity of the terms in the document. If the terms occurs close to each other, so if the terms occur is close to each other, then the document will be ranked higher than if they occur as a four apart. So whatever the content that is used, that is available in the document, that will be used as a higher frequency that is used for the document. The formula for R, that is DQ, can be modified to take proximity of the terms into account. So whatever the term that is used, that will be defined by the number of terms that will be used by the proximity of the terms that is taken into account. Given a query Q, the job of an information retrieval system is to return the documents in descending order of their relevance to the queue. And there will be a large number of documents that are relevant for the information retrieval, that is used as a query of the information retrieval, that provides the proximity of the value, that provides the content of the value, that contains multiple documents in a defined manner. Then similarity based retrieval, that is a similarity based retrieval that is used as a document. Next is a similarity based retrieval, that is how to retrieve the information, that is a similarity based retrieval. So certain information retrieval permits a similarity based retrieval that contains information. So there will be a same kind of information that is used, that is a similar based information that is retrieved from the database systems. Here the user can give the system document A and ask the system to retrieve documents that are similar to A. So whatever the document that is used, that is similar to the A, whatever the content that is used, that is very similar to the A, that is occupied in the various documents. The similarity of a document to another may be defined, for example, on the basis of the common terms. So whatever the terms that is used, whatever the content that is used, that is defined with the various terms as a common terms. One approach is to find k terms in A with highest value of TF ATT is multiplied by the ID of T, and to use these terms as a query to find the relevance of their document. So whatever the content that is used, whatever the document that is used, that is defined with the relevance document, that is used with the various document that is defined in the content of the structure. The terms in the query are themselves weighted by TFAT and are multiplied by the IDFT. So whatever the content that is used, that is multiplied by the IDF and that is multiplied by the TFAT. More generally, the similarities of document is defined by the cosine similarity metric. So whatever the metric that is used, that is defined by the cosine similarity metric. Let the terms occurring in either of the two documents be T1, T2 and the Tn. Let RDT is equals to TFDT into IDFT. Then the cosine similarity metric that is used between the document D and D is defined as this one. It is defined in this follows. So you can easily verify that the cosine symmetry or similarity metric of a document with itself is 1. So one can increase the cosine symmetric matrix, one can increase the cosine symmetric metric of a document that is used with a document that is used with the two documents that do not share any terms in the, or that is that share something between the similarity between them is a 1, and while the similarity, there is no similarity, that do not share the term, that is a 0. The name cosine similarity comes from the fact that the above formula computes the cosine of the angles between two factors, one representing each document. So one of the factors is representing another document, another factor is representing the another document. The model of documents is used as a points in the vector in an n-dimensional space is known as the vector space model. So whatever the model of document, whatever the content that is used, that is defined as a point in the vector in an n-dimensional spaces, that is known as the vector space model. And the resulting set of documents is likely to be what the user is intending to find, and the idea is known as the relevance feedback. Relevance feedback can also be used to help users to find relevant document from a large number of document or a large set of document that matching the given query keyword. So whatever the query that is used, whatever the relevant document that is used, that is defining the large number of documents that matches the given query keywords. In such a scenarios, user may be allowed to identify one or more few of the returned document as a relevant document. Now, how to use the relevance using the hyperlink, that is how to use the relevant method, how to what is the use of relevancy in terms of the hyperlink, that is how to denote the relevancy with the hyperlink. So every search engine or every web search engine rank document by using only TF and the IDF based relevance measure that we have already discussed. So if I search for anything, if I search for any information from the web search engine that is used, so that contain multiple information, and that ranking of the document that contain first link, second link, third link, that is defined by using the TF-IDB based relation measures or relevance measures that is already defined in the 21.2. However, these techniques have some limitations when used on a very large collection of documents, such as the set of all the pages. So whatever the document, whatever the technique that is using, that is containing the large number of documents, such as the set of all the web pages. In particular, many web pages that have all the keywords specified in a typical search engine query for the sum of the pages that users wants as an answer often have just a few occurrence of the query terms. So there are multiple information that is retrieved, that is getting the information, that is getting the few occurrences of the query terms, and we would not get a very high TF-IDF score that is used with the relevance of the document. So that is relevancy is also provided, is also defined by using the hyperlink that is available with the document method. Next, however, researchers soon realized that web pages have very important information that plain text document do not have, because there are multiple information that is available, and we can jump from one page to another page to another. So there will be a hyperlink among the various parts, among the various contents of the web pages. That is, there are multiple information that is used as a plain text and that do not have, namely the hyperlink. So the hyperlink will be used to divide the information, denote the information, or we can say the move the information from one part to the another. So, however, researchers soon realized that web pages have any important information that plain text documents do not have, then namely the hyperlinks. These can be exploited to get better relevance ranking. In particular, the relevance ranking of a page is influenced greatly by the hyperlink that point to the page. So, whatever the point that is used, whatever the content that is good, that is pointed by the hyperlink of the web pages, that is denoted by the web pages. The next is the popularity ranking. So whatever the popularity ranking that is used, that is known as the prestige ranking, that is to use to find the pages that are popular. So the basic idea of the popularity ranking that is used, that is defined with the popular method, and to rank them higher than the other pages that contain the specified keyword. So whatever the specified keyword that is used, whatever the ranking that is used, that is defined in the various terms, that is defined in the various content of the matter. Since most searches are intended to find information from popular pages, ranking such pages higher is generally a good idea. For example, the Google may occur in the vast number of pages, but the page google.com is the most popular among the pages that contain the term Google. So whatever the Google that is available, that will contain the term Google. So if I apply the google.com, that will be available in the term google.com. The page google.com that will be ranked is the most relevant answer to a query consisting of the term Google. So whatever the term Google that is available, that is used with the google.com. So if I search for a Google information, if I enter the google.com, that is a relevant page will become that we can search any information from the Google. We can say the Google is a search engine that is used to search any information that contain multiple hyperlink, that is used to search information from one page to, or that is used to send the information from one page to another page. Traditional measures of the relevance of a page, such as the TF-IDF based measures that we saw in the 21.2, can be combined with the popularity of the page to get an overall measure of the relevance of the page to the query. So whatever the popularity that is available, that is contained in the overall measure of the relevance of the page to the query, that is used with the various measurement that is used in the relevance of the page. Pages with the highest overall relevance value can return to the top answers of a query. So whatever the top answer that is used, that is returned to the top answers of a query that is used with the various documents. This raises the question of how to define and how to find the popularity of a page. That is, how to define the query, then how to find the, or how to define the popularity of a page that is available in the documents. One way would be to find how many pages are available or how many times a page is accessed. So if you are clicking on the page that is displayed the information that you have visited 2 times on this one, on this date, that is, it maintains the cookie, it maintains the record of each and every information, that is how many times the user visited the same page, how much time, or what is the duration of visiting the same page, what is the main content of visiting the same page, and what is the criteria for visiting the same page, and what is the main advantage of visiting the same page again and again and again. This raises the question of how to define and how to find the popularity of a page. That is, how to define the page and how to define the popularity, that is how popular is a page is available. However, getting such information is impossible without the cooperation of the site. So if there is no cooperation in the site, so there is very difficulty to find the information, relevant information in the site. While a few sites may be persuaded to relieve this information, it is difficult to get it for all the sites. And many sites are available about their access frequency, and many lie about their access frequency in order to get ranked higher. An effective alternative is to use the hyperlink to a page as a measure of its popularity. So we can use the popularity by using the hyperlink, that will be used as a measure of the popularity that is defined in the terms of the popularity. Many people have bookmarked files that contain links to the site that they frequently use. So most of the bookmark or most of the files have a bookmark, that is they tie up a tag that is a bookmark that contain link to the site, that is a this site will be visited 5 times, this site will be visited 5 times, that will contain a bookmark that is used as a popularity. Bookmark files are usually stored privately and not accessible on the web. So whatever the bookmark file that is used, that is stored on the that will be usually stored privately and not accessible on the web, that is used in the bookmark page. However, many users do maintain web pages with the link. So whatever the web page that is used, that will used to maintain the web pages on the that is used to maintain the web pages on the link. However, many users do maintain web pages with links to their favorite web pages. Many websites also have links to other websites, which can also be used to infer the popularity of the link sites. And the search engine that is used to search the web pages, that is a process that is defined, that is a crawling, which we describe in 21.7, that is the next part, and analyze to find the link between the pages. So whatever the page content that will be available, whatever the content that will be available, that will be defined in the search pages, that will define the content that will be available in the content of a web pages. A first solution to estimating the popularity of a page is to use the number of pages that links to the page as a measure of popularity. So whatever the popularity measure, whatever the content that will be used, that is a number of pages that is linked. So how many visited it, or how many times we visited the same page, that page is popular that times also. So the other pages would be wrongly inferred to not be very popular and would create a low ranking in answering the query. So that will be go low, low, low. That is the first page is the highest priority page that visited multiple times, or that the user visited many times on the same page. Now, one alternative to associate the popularity with the sites rather than with the pages. So one alternative is to use the popularity with the site. So use the popularity, or use the popularity terms with the site, not with the pages. All the pages at a site then go get the popularity of the sites, and pages other than the root page of the popular site would also benefit from the site's popularity. However, the question of what constitutes a site then arises. So what constitutes a site? What is the main criteria of constituting the site? That also arises another question. In general, the internet address prefix of a page URL would consist the site corresponding to the page. So whatever the site that will be used, whatever the content that will be used, that will be available on the web page, that will be available on the website. And there are many sites that host a large number of mostly unrelated pages. There are multiple unrelated pages that is also available, that contains on the page servers. And for example, a page server in the university and the web portal such as the groups.yahoo.com or the groups.google.com. For such sites, the popularity is used, or that does not imply the popularity of another part of the site. A simple alternative is to allow transfer of the prestige from popular page to the pages to which they link. So whatever the content that will be used, that will be popular to the content that will be used in the site, that will be used as a content under which the scheme by one person can vote for the democracy of another person, by which the popular pages of one page to the page y decides the conferring more prestige to the y that the link from a not so popular page. And the notion of popularity is in fact circular, since the popularity of the page is defined by the popularity of another page. So if one page is popular, another page is also popular. That is that there will be a chain among the popularity, popularity that will be used, that is used in the defined terms. That is how to use the popularity, and how to getting done with the popularity of the defined terms. This notion of popularity is in fact circular, since the popularity of a page is defined by the popularity of other pages. The linear equation can be defined in such a way that they have a unique and a well-defined solution. So there will be a linear equation that will be defined in such a way that they have a unique and a unified or well-defined solution. Now next is a page rank, that is how the search engine maintains the pages. If you see, there are multiple pages that is available if you search any information. So what is the main criteria, that is how to rank them, which page to come first, and then which page, then which page. So the web search engine Google introduced PageRank, which is a measure of the popularity of the page based on the popularity of the pages that links to the page. So whatever the page that is available that is linked to the another page that is used with the website, that is used with the web pages that is used, that contain the multiple information on the web pages. Using the PageRank popularity measure that is used, that is based on the popularity of the content that is used, that is defined in the various terms, that is defined in the various manner, that will be defined as a popularity of the page. PageRank can be understood intuitively using a random walk model. Suppose a person browsing the web performs a random walk, that is traversal on the web pages as follows. The first step starts at random web page. So whatever the random web page that is available, that is used as a random web page, and each step the random walker does one of the following. With the probability the walker jumps on the random web pages, and with the probability of 1 to 8, the walker randomly chooses one of the outlinks that is available with the current web page and follows the link. Note that the pages are pointed to from many web pages that are most likely to be visited and therefore have a higher page rank. So whatever the page rank that is will be used that have a higher page rank, that is defined in the pages of the rank. Page rank can be defined by a set of the linear equations. So page rank can be defined by a set of the linear equations that will be defined that they have a different probability that is contained with the t, that is defined with the Tij. Now other measures of popularity, that is how to measure, or what are the various measures by which we can measure the popularity, that which page is more popular than the other page. That is, if I am searching something, 3 pages are come, and which page is more popular than the other page. The basic measures of popularity such as the page rank plays an important role in ranking of query answers, but there are but are by no means the only factor. The TF-IDF scores of a page that is used are used to judge its relevance to the query keyword and must be considered with the popularity ranking. So whatever the popularity ranking that is used, whatever the content that is used, that is defined in the popularity ranking, that is defined with the, or that is combined with the popularity ranking. Other factor that must be taken into account to handle limitations of page rank and related popularity measures. And information about how often a site is visited would be a useful measure of popularity, but as mentioned earlier, it is hard to obtain in general. However, search engine do track what fractions of time users click on page when it is returned to an answer. This is another measure, that is how many times when we click on the site, that is there are multiple hit that is available on the site, and that hit will be considered as the popularity of the various sites. And the one of the drawback of the page rank algorithm is that it assigns a measure of popularity that is does not take query keyword into account. For example, the page google.com is likely to have a high page rank because many sites contain a link to it. Suppose it contains a word mentioning in passing such as a Stanford or advanced search page that is available, that is used to define the web pages that is defined in the various web pages available. So this is AHREF. This is the most widely used HTML tag, that is the AHREF, that is the anchor reference tag that is used as a link. So for example, this is AHREF flag. If I click on this one, this will allow the content that is also visited to the Stanford University, that is stanford.edu. This HTML content that is used as a hyperlink. So when you click on the link, the page will be available to the Stanford link. If many links to the page Stanford have a word Stanford in their anchor tag, the page can be judged to the relevant measure that can be used as a relevant measure for defining the measure terms. An alternative approach to using the account while defining a popularity is to compute the popularity by using the pages that contain the query keyword that is used as the various search engine that is used as a various querying that is used with the various measures that is used with the query measures. Now the next is search engine spamming. So there is also a concept that is known as the search engine spamming, that is refers to the practice of creating web pages or design the web pages that have a high relevance rank for some queries. So designing only those pages that have a high ranking. So if I am visiting the page 5 times, that is a high ranking page. So making the practice or design the practice or that have a high relevance rank for some queries, even though the sites are not actually popular sites. So whatever the site that is available, that is not a popular site that is used, that is not available for the popular site, that is not the site that is popularly used. For example, a travel site that may want to rank high for queries with the keyword travel. So whatever the travel site that may want to rank the high for the queries that have a keyword to travel, it can get the high TF-IDF scores by repeating the word travel many times in its page. So whatever the travel terms that is used, that is defined in that page, 3 times that is available in the site. So that is a TF-IDPF column that was common in the early days of the web search, and there was a constant battle between such sites and the search engine that has tried to detect the spamming and deny them high ranking. So whatever the high ranking that is available, that whatever the ranking that is available, that is denoting the high ranking term that is defined in these terms. Popularity ranking schemes such as the page rank make the job of search engine spamming more difficult. So whatever the spamming ranking that is used, that makes the job more difficult, just repeating the words to get a high TF-IDF score, that is just visiting the same, we can say the same page again and again, that is also increasing the page ranking. And techniques such as using the sites instead of pages as a unit of ranking have been proposed to avoid some spanning techniques. So whatever the spanning technique that is used, that will be defined to avoid the spamming technique that is used to define the spamming content that will be available in the content of the major sites. The war between search engine spammer and the search engine continues even today. So whatever the search engine spamming, whatever the search engine criteria that is also used in the day-to-day scenario, that is also used in the, we can say, the spamming procedure that is not in the content of the spamming options. The hubs and the authorities approach of the HITS algorithm is most acceptable to the spamming. So whatever the hubs and the authority that is available with the hits approach, hits algorithm, that is most acceptable to the spamming. A spammer can create a web page containing links to good authorities on a topic and gains a high superiority or high hub secure or score as a result. Then next is the combining TD or TF, IDF and popularity ranking measure. So whenever there will be a demand that will be combined, or that we can combine the TF, IDF or IDF and the popularity ranking measure, that will be defined the popularity measure that will be used as a ranking, that will define the terms that is used with the TD, or so that we can gain the advantage of both the TF and the IDF scores such as the page rank. So how to combine the scores of a page on each these factors to generate an overall page score is a major problem that must be addressed by or addressed by any retrieval system. So whatever the retrieval system that is used to gain the factor, that is used to gain the overall page score, that is a major problem that must be addressed by any information retrieval system. In the early days of the search engines, humans creates relations or functions to combine scores into overall score. So whatever the overall score that will be used, that is used to combine the overall score, that is used to combine the scores into overall score. But today, search engines use machine learning techniques to decide how to combine the score. So whatever the combination, whatever the search engine that will be used, that is used to combine the score, that will be available in the content of the scores. Typically, a score combining formulas is fixed, but the formula takes a parameter weights for different scoring mechanism for different scoring factors. We note that most search engines do not reveal that how they compute the relevance ranking, how believe they are relieving their ranking schemes. Now next is synonyms or synonyms, homonyms and the ontologies. So whatever the synonyms that are similar words, homonyms that have a similar sounds, and the ontologies that is also available in the content of the database, that is also available in the content of the manufacturing or the database. The document title motorcycle repair would not be retrieved since the word maintenance do not or does not occur in its title. That is a synonyms. Next is the synonyms, homonyms and the ontologies. So consider the problem of locating the document, that is how to locate the documents or the motorcycle maintenance. Consider the query or using the query, that is a motorcycle maintenance. So take the query, that is a motorcycle maintenance. Suppose that the keywords for each document are the words in the title and the names of the author. So whatever the author name, whatever the title name that is will be used, that will be used as a keyword document, that will be used as a keyword. So consider the document that is a motorcycle maintenance that is used. So suppose that the keyword for each document are the words in the title and the names of the author. The document title motorcycle repair will not be retrieved since the word maintenance do not or does not occur in its title. So whatever the word that is used, that is the maintenance word that is used, that does not occur in the title, that will be used as a maintenance title, that will be used as a keyboard title. So we can solve that problem by making use of the synonyms. So we can use the synonyms that is used, that is define the terms. Each word can have a set of synonyms that is defined, and the occurrence of a word that can be replaced by the all of its synonyms that is using the words. Therefore, the query that is a motorcycle and the repair can be replaced by motorcycle and the repair or maintenance. So we can use any term that we can use any term that is a synonym word that is a repair or the maintenance because they have the same meanings. That is the same word that is a repair or maintenance. This query would find the desired document. Keyword-based queries also suffer from the opposite problem of synonyms, that is a single words with multiple meanings. So synonyms means the same word, same meaning, that is similar words have the same meanings, that is different words have the same meaning. In this single words have different meaning or multiple meaning, that is a homonyms. For example, the word object has different meaning as a noun and as a adverb or as a verb. The word table may refer to the dinner table or a table in a relational table. So whatever the table that is used, that is a table that is will refer to the dinner table or a table in a relational database. In fact, danger even using synonyms to extend the queries is that synonyms may themselves have different meanings. For example, allowance is a synonym for the one word of the one meaning of the word, that is a maintenance, but has a different meaning than what the user intended in the query. So whatever the user intended in the query, that is a defined in the query, that is a motorcycle maintenance. Document that use the synonyms with an alternative intended meaning would be retrieved. The user is then left wondering why the system thought that a particular retrieve information is relevant if it contained neither the document, neither the word specified that is used with the synonym that is used with the keywords. A better approach to the above problem or the synonym problem, that is using what concept each word in a document represent, and similar to the understand what concept a user is looking for. So what are the concept that is user is looking for, and to return the document that address the concept that the user is interested in. So whatever the concept that is used, whatever the term that is used, whatever the system that is used, that is representing the term that is used in a document. A system that supports concept-based querying has to analyze each document to disambiguate each word in the document. So there is a system that supports the concept-based querying that is used to analyze each document, that is used in a disambiguate each word in the document and to replace it with the concept that it represents. Disambiguation is usually done by looking at the surroundings words in the document. For example, if a document contains words such as a database or query, the word table probably should be replaced by the concept that is a table data. Whereas if the document contains words such as a furniture, chair or wood near the word table, the word table should be replaced by the concept table furniture. So any term will be used, that is the table furniture or the furniture table. Disambiguation based on the nearby words is usually harder for such queries. Since queries contain very few words, so the concepts become very easy. There will be alternative method, there will be alternative concept to the user, or pick up one or more before the search continues. Concept-based querying has several advantages that is used. For example, a query in one language can retrieve documents in another language. So whatever the query that is used, that will be used to retrieve the document in other languages, so long as they relate to the same concepts. Automated translation mechanism can be used subsequently if the user does not understand the language in which the document is written. So whatever the language that is used, whatever the language or whatever the document that is used, that is defined or used to define the concept that is used in the ambiguity of the problems. Internet search engines therefore generally do not support or didn't support concept-based querying initially, but interest is in concept-based approaches is growing rapidly. So whatever the search-based engine, whatever the concept-based querying initial value, that the interest is going on repeating again and again and again. However, concept-based querying system have been built and used for other large collection of documents. So whatever the collection of document that will be used, that will be initiated by the document, that will be initiated by the concept-based querying, that will be using the large concept of or large collection of documents. Querying based on the concepts can be extended further by exploiting a concept hierarchy. For example, suppose a person issue a query that is flying animals. A document containing information about the flying mammals is certainly relevant since a mammal is an animal. However, the two concepts are not the same, and just matching concepts would not be allowed the document to be returned as an answer. So whatever the content, whatever the system that is used, that is a flying animals or flying mammal, that is relatively the same, that contains the various information. Concept-based querying system can support retrieval of document based on the concept hierarchy. So whatever the concept-based querying system that is used to define the, that is used to support the retrieval of document that is based on the concept queries. Now, these are the homonyms, that the single words have a different meaning. Synonyms, the same word had the different words have a same meaning, that is the similar words. Now, next is ontologies, that are hierarchical structure that reflect relationship between the concepts. So, whatever the concepts, whatever the relationship that is used, that is using the concept of the hierarchical relationship. The most common relationship is a relationship. For example, leopard is a mammal. So it is a relationship that is used, that is a leopard is a mammal and mammal is a animal. Other relationships such as a part of are also possible. For example, an aeroplane wing is a part of the aeroplane. So there are two types of relation in this defined, that is a relationship and the part of a relationship. The word net system defines a large variety of concepts with associated words such as that is used in the word net terminology. The words associated with the sign set are synonyms for a concept. For example, it will be a synonym for the different related concept that is used. In addition to the synonyms, WordNet defines the homonyms and the other relationship also. And there are two relations that is used, that is a relation and the part of relation, that define the connect terms or concepts, and in effect defines an ontology. So there is ontology that is used, and the psych keyword or psych project is another effect to create an ontology. That is how to create a relationship or define the relationship between the two entities, between the two concepts. That is a relationship and the part of relationship. That is ontologies. In addition to the language-wide ontologies can be defined for specific areas to deal with the terminology that is relevant to the those areas. So whatever the area that is used, that is deal with the terminology, that is deal with the concept that is relevant to the area, that will be defined in the language-wide ontologies. For example, ontologies have been created to standardize terms used in businesses. This is an important step in building a standard infrastructure for handling the order processing and other inter-organization flow of data. So whatever the flow of data, whatever the concept that is used, that is defined in the various inter-organization flow of data, that is defined in the concept of the inter-organization terms. As another example, consider a medical insurance company that needs to get report from hospitals that containing diagnosis and treatment information. So whatever the treatment, whatever the diagnosis information that is used to define the concept of the various terms. So an ontology that standardize the terms help hospital staff to understand the report unambiguously. This can greatly helps in analysis of the report. For example, to track how many cases of a particular disease occur in a particular time frame. So whatever the time frame that is used, whatever the content that will use, that will be used to define the terms in the database systems. It is also possible to build ontologies that link multiple languages. For example, WordNet have been built from different languages, and common concept between the languages can be linked to each other. So whatever the concept, whatever the languages that will be used, that is defined in the different concepts, that is used to define in the various terms, that is used to define in the various, we can say, the flow that will be used in the defining the terms. And the largest effort that is used in using the ontologies for concept-based querying is the semantic web. So whatever the semantic web, that is led by the www consortium and consists of the collection of the tools, that is a semantic web that is defined by the www, that is the W3 consortium, and consists of collection of the tools, that collections of the standards and the languages that permits the data on the web to be connected based on their semantics. So whatever the data that is available, that is based on their semantic, based on their value, based on their meaning. Instead of being a centralized repository, the semantic web is designed to permit the same kind of the data, that is to be decentralized among each other, or decentralized, that is a I'm sorry, that is to decentralize among various parts, that is a semantic web. And as a result, anyone with access to the internet can add to the semantic web. Now, how to index the document, that is how to maintain the indexing in the documents. I'm just coming within 2 minutes. So next is the indexing of the document, that is how to maintain the indexing, or maintaining the indexing of the documents is a very important feature, because different mechanism, different index structure is important for efficient processing of the query. So whatever the processing query, whatever the query that is used in the processing, that is retrieved in the information retrieval system. So index structure is very important for efficient processing of the queries in an information retrieval system. A document that contains a specified keyword can be located efficiently by using an inverted index that maps each keyword KI to the list SI. So, for example, if you use using the control F, that is used for the searching, that is used for searching the index that map the keyword, that is the KI, to the list SI of the identifiers of the document. For example, if a document D1, D9, D29 contains the term silver chats, the inverted list of the keyword, that is silver chats, will be would be D1, D9, D21. To support the relevance ranking based on proximity of keywords, such as the index may provide not just identifiers of the document, but also a list of the locations within a document where the keyword appears. For example, if silver cats appeared in the position 21 in D1, position 1 and the 19 in D2, and position 426 or 29 46 in D3. Such indices must be stored on the disk, and each list SI can span the multiple disk pages. To minimize the number of input-output operation to retrieve each list, SI will be attempt to maintain list that is available in the disk pages. The end operation will be used to find a document that contains in a specified keyword, that is a K1, K2 until K. The first part that contains the document that have high TF score for that term that appears in the document title. Now, how to measure the retrieval effectiveness, that is how we can measure, that is how many times the data will be retrieved, that is how to measure the retrieval effectiveness. So every keyword must be contained in a large number of documents, hence a compact representation is critical to keep space uses of the index low. So whatever the low field, whatever the content that will be used, that contains number of, or that contains, or every keyword may be contained in the, or each keyword may be contained in the large number of documents. Suppose if I am finding the term or finding the keyword, that is the is, that will be available in the large number of documents. Hence, a compact representation is critical to keep space uses of the index low. Therefore, or thus the set of documents for a keyword are maintained in a complex form. So whatever the content that will be used, that is will be available in the context form, that will be available in the complex form. So that the storage can be saved, or storage space is saved, the index is sometimes stored such that the retrieval is approximate and the few relevant documents may not be retrieved. For example, a false stop or the false negative, and a few irrelevant document may be retrieved. So few relevant information will be retrieved, and few irrelevant information may also be retrieved, such as the false stop or the false negative, and also known as the false positive, that is the irrelevant information. That is very good, that is a fall down, because this is very irrelevant information that is not structured. A good index structure will not have any false stops, but may permit a few false positives. The system can filter them away later by looking at the keyword that they actually contain. In web indexing, false positives are not desirable either, since the actual document may not be quickly accessible for filtering. So whatever the false document, whatever the false content that will be used, that is not desirable, that is not quickly accessible for the filtering. Two metrics are used to measure how well on the information retrieval is able to answer the query. That is how well information retrieval system is used to able the query, is used to able the or answer the query, whatever the metric that is used. The first precision measure, that what percentage of retrieved information are usually relevant to the query. The second, what measures will be used, what percentage of the document that is relevant to the query will be measured. So these are the various questions. The first is precision, that is what percentages are actually relevant to the query. The second one is recall, that what percentage of the document are relevant to the query or retrieve, that is the percentage that is defined. Then ideally both should be 100%, that is both measures, or both we can say the precision measures as well as the recall method measures should be 100%. Precision and recall are also important measures for understanding how well a particular document ranking strategy performs or performs. So whatever the strategy, whatever the measure that is used, that is how well a document, how well a particular document ranking strategy perform, or how well a different strategy perform the different criteria, and that can result in a false negative and the false positive, but in a more subtle manner. So ranking strategy can be available in the false negative manners or in the false positive manner, but in a more subtle manner, that is more in a defined manner. When we talk about the false negative, that may occur when documents are ranked as a result of relevant document receiving a low ranking. So if the documents are ranked with each other and there will be a low ranking that is received, so there will be receiving of the low ranking, and the system fetched all the document down to those with very low ranking, there will be a false negative also. False positive may occur because irrelevant document gets a higher ranking. A better and the more intuitive approach for measuring the precision is to measure it at the function of the recall. So whatever the function that is used, that is how to recall the system, and with this combined measure, both precision and recall can be computed as a function of, or the function of the number of documents if required. For example, if we say that with a recall of 50%, the precision was 75%, whereas a recall of 75%, the precision dropped to the 60%. So 50 to the 75 and the 75 precision to the percentage to the 60 percentage. In general, we can draw a graph relating precision to the call. So whatever the content will be available, whatever the data will be available, that will be available in the content of the database storage. These measures can be computed for individual queries, then averaged out across a suite of queries in a query benchmark. Yet another problem with measuring the precision and recall lies in how to determine which documents are really relevant and which are not. So that is also, we can say, the measure that is also one of the biggest problem, that is how to determine which documents are relevant documents, which documents are used for the better productivity, and which documents are not used for the better productivity. Researchers therefore have created collection of documents and queries and have manually tagged together or have manually tagged document as relevant or irrelevant to the query. So researchers have tagged the document as a relevant document and the irrelevant document that is recalled with the document that is recalled with the manual tag information, that is relevant or irrelevant to the queries. Different ranking system can be run on these collections to measure their average precision. So whatever the average precision, whatever the average run that will be used, so different ranking mechanism have a different queries that could be run on collection to measure their average precision and recall across the multiple queries. So there will be multiple queries that will be used, that is defined in the multiple options of the queries. Now next is the crawling and indexing the web, that is how to crawl the web and how to index in the web. This is one of the important topic. So I'm going to start right now or tomorrow, because this is the important topic. So let's stop over here only. In the next class, I'm taking a next topic, that is crawls and page ranking, that is use the crawling, how to use the crawls, and what are the various methods to use the crawl and the page ranking that will be available, that is indexing the web. So this is the crawling and the indexing the web that will be available in the page ranking. So that's all for today's session. I'm winding this class because this is the important topic and there's no more time left for this main important topic. So let's stop the class over here only, and in the next class, that is in the tomorrow's class, I'm taking the next topic or this topic, that is the web crawling or the crawling and indexing the web. So that's all for today's session. If there is any doubts, any suggestions, any query, then you can ask the doubts from me. So thanks a lot everyone for listening me. We will meet tomorrow with a new topic, that is the crawling and indexing the web. So thanks a lot everyone. Bye bye.